In this video, we're going to be tackling the LeetCode question, search and rotated sorted array. And I touched upon array rotations very briefly in a previous video, but I'm just going to come out and say it again. Grocery store employees, the people that stock the shelves with food near you, they've been lying to us this whole entire time because they've been taking the stale food in the back and putting it in the front so that people eat the stale food first. And I'm not going to let it slide anymore. I'm here for justice. But what exactly does that mean? Well, array rotation works very similar in computers. What's going to happen is that the store clerk, the person that stocks the shelves, is going to take the old numbers, the moldy peanuts, the stale peanuts in the back, and he's going to just toss them up in the front, just all willy-nilly, like nobody even cares. And that's how array rotations work. And you've learned what array rotations are, but how exactly are we going to search a rotated array? Luckily for us, there's only a couple searching algorithms to even choose from. And besides that, LeetCode's going to pretty much tell you in the description with this phrase right here. Algorithm must be log n. Whenever you see log n, I honestly would probably bet $1,000 that it's going to be a binary search. Literally a 99% chance that binary search is the searching algorithm that they want you to use if you see log n. But this seems a little bit too easy. LeetCode patterns are never this easy to identify. What is the catch? Well, the catch is this. With a traditional binary search, pretty much any binary search that you use, you're going to have the numbers 100% sorted. The numbers have to be in sequential order, one by one. Nothing can be out of order because a binary search works very similar to a phone book. Think about a phone book. If the numbers are out of order, you would never even be able to use it. And a binary search works very similar to how we search for a number in a phone book. Let's say that we're searching for 7 in this array right here. All that we're going to do is cut it in half. We're going to start searching right in the middle. Then we're going to identify if the number is on the left or the right side. And then we're just going to cut in the middle again. And 7 is in the second middle that we try on. And that's how the binary search works. And that's the reason that it's so fast. But how exactly are we going to do this in a rotated array? Well, look at it like this, and this is the most important part of the whole entire video. If you don't pay attention to anything else, pay attention to this one part. Just like a regular binary search, what we're going to do is we're going to start smack dab in the middle, always. But notice something. Look at the numbers to the left of the arrow. Look at the numbers to the right of the arrow. Notice something peculiar. One side of the arrow is always sorted. And when I say always, I mean always. In a rotated array, if you put an arrow right in the middle, without doubt, and I encourage you to test this on arrays yourself, one side of the array will always be sorted and one side will not be. And with that in mind, we can just create a binary search that sorts on the sorted side. What exactly do I mean by that? What we're going to do is we're just going to add a little extra step, a little extra piece of logic. And we're going to check if this number is less than this number. And if this number is less than this number, then it means that the array is sorted. And we're going to search on this side. And let's just say that we're searching for 3. 3 is right in the middle. Congratulations, we found the number that we're looking for. But that's kind of a simple case. What if we have a number that's on the non-sorted side and it's deep in the non-sorted side? How exactly is that going to work? Well, in this case, we're going to search for the number 9. The number 9 is on the non-sorted side of the array, and the process isn't going to be much different. What we're going to do is we're going to search on the sorted side. We always want to search on the sorted side of the rotated array. But the bad thing is that 9's not in the sorted side. So what are we going to do now? Well, we're going to pretty much logically block out these numbers. And when I mean logically, what we're going to do is we're going to move our pointers over so that we don't search that side anymore because the number's not over there. Why would we search there anymore? But the thing is that we're no longer on the sorted side of the array. So what are we going to do now? We're going to find the other sorted side. And what exactly do I mean by that? Well, what we're going to do is we're going to place our arrow in the middle just like we did before. And even though that we've chopped this array in half, there's still a side that's going to be sorted. It's almost like a tessellation. No matter how many times you chop this array in half, there's still going to be a side that's sorted on the rotated array. It's kind of crazy to think about, but it's almost like a law. It's true no matter how many times you chop it in half. And when we search on the left side, we find our other sorted side of the array. But the bad thing is that 9's not over there, so what are we going to do? Well, we're going to do the same exact thing again. We're going to go ahead, place our arrow in the middle, which is going to be 8 this time. And this time, the right side is sorted, so the next time that we iterate, we're going to find the 9. And that's pretty much the algorithm, pretty simple. So let's go ahead, let's hop over into IntelliJ, and let's code it. So we are inside of IntelliJ, and the first thing that I'm going to do is create a brand new Java class. I'm going to call this solution. Within the solution class, we're going to house our method for the actual algorithm. This method is going to be public. It's going to return an int, and we're going to name this search. And it's also going to take in an integer array of nums. It's also going to take in the target, which is the number that we want. So a binary search, believe it or not, is very similar to a two-pointer style LeetCode question. We're going to have a pointer that starts at the very beginning, and we're going to have a pointer that starts at the end. And we're also, in typical two-pointer fashion, we're going to have a while loop with an expression in it that says if left is less than or equal to right. And that's going to basically make sure that those boundaries of left and right do not cross. We don't want those boundaries crossing. We're also going to find the mid. And nowadays, whenever people find the mid in a binary search, they do it like this. And this way, even though it's more complicated than just having left plus right divided by 2, is going to prevent integer overflows. But you could just have left plus right divided by 2 if you wanted to. I think it still actually works. So next thing that we're going to do, we're going to check if the mid is equal to the target. Because we're always splitting down in the middle, because we're always quote unquote searching in the middle of the dictionary, if we land on the middle, that's the number that we want. And we're going to go ahead, fail first or have success first. Fail first or success first is a good strategy to use when coding algorithms. And if we find the number that we want at the very beginning, we don't want to do any more searching. So this right here is going to be logic that's going to check for the sorted side. It looks pretty complicated, but I'm going to explain it to you in very simple terms. So we're going to say if the number at the very left, so let's just say we're starting at the very left, is less than the mid. So how exactly is this going to determine if it's sorted? Let's go back to the array example, and let's just say we land in the mid. We're going to land on the middle once again. So if we land on the middle, if this number is less than this number, this is the sorted side. But let's just say we're searching on this side, and this number is actually going to be greater than this number, which is not what we want. That means it's not sorted. So that's the logic that's going to take care of finding which side is sorted and which side is not. And just to kind of get things ready, I'm going to go ahead and create an else statement because it's going to search the other side if it finds that side is not sorted. So if we're on the sorted side, here's where we're going to actually check if the number's on that side. We're going to say nums left is less than or equal to the target. We're going to basically check within the boundaries, and we're going to say target is less than nums mid. And if target is less than nums mid, what we're going to do is we're going to reassign our pointers. We're going to reassign our boundaries. I'm going to say mid -1. Then I'm going to create the other logic that's going to execute if that number is not on that side. And if it's not on that side, we're going to move our left pointer over mid +1. Okay, so that's pretty much the bulk of the logic. Now we're going to have to just do the other side. So if the sorted side is on the, let's say, the right side, what we're going to do is we're going to check nums mid. So we'll say nums mid. And this is just the boundary checker to see if it's within the boundaries. We're going to say target, and target is less than or equal to nums.right. We're going to move over our left. So go ahead, mid +1. I'm going to go back down here. The algorithm is getting kind of long. I'm going to do the exact same thing. I'm going to say right is equal to mid -1. And last but not least, if we don't find any number, we're going to return -1 at the very end to signify that number that we searched for does not exist. So I'm just going to go ahead, grab everything from the return -1 up, and I'm going to go ahead and copy this. We're going to get out of full screen here. I'm going to toss this into LeetCode and see what we get. So bring this over, go ahead, put the code in the editor, move this one over, make it look good. Let's go ahead, hit that run button, see what we get. Thank you, God. Test case is passed. Let's go ahead, hit that submit button. We have to be logged in. Let's make sure that we are logged in here. And we are looking good. We are logged in. Our memory is also constant as well too. Hope that you guys enjoyed this. If you did, smash that like button, smash that subscribe button. And as always, thank you for watching.